So, as we move away from free body diagrams and forces that impact on our motion, it's time to start thinking about what happens when we have particles or items that run into each other. We're going to start looking at what if two things or more than two things collide. So, let's think first of all, if you were to get into a collision, let's say a bumblebee runs into you. Now, I'm not talking about a stinger because that would hurt, but let's say you run into a bumblebee or you run into a baseball. Let's say the bumblebee is flying at top speed and maybe that's 25 kilometers an hour. So let's say this bumblebee flies into you at 25 kilometers an hour, or a baseball hits you at 25 kilometers an hour. Or let's say the school bus hits you at 25 kilometers per hour. Which one of those do you think would hurt the most? Or would it all be equal? Well, I hope you recognize that the school bus is most likely to do the most damage. So the question is, why? And the answer is that the school bus has the most momentum. So why is it they're all going at the same speed? Well, you'd probably say that the school bus is bigger, and that's right. And it's not necessarily the size of it, but it's the mass that it hits you with. School bus with thousands and thousands of kilograms is going to cause a lot of damage, as opposed to that little bumblebee that might weigh 100 grams. So the more mass something has, the more momentum it's going to have. Now let's look at what else. Well, what if that school bus was going at 5 kilometers an hour compared to 50 kilometers an hour? Does that make a difference? And I think you would recognize that the faster the object is going, the more damage it would do as well. And so what we need to do is figure out the influences that affect our momentum. And it's really two things. It's the speed in which the object is traveling and how much mass it has. So let's go and look at a formula and practice solving some simple problems. So the momentum is represented by a lowercase p. That's the symbol for momentum. And it is the mass of the object represented in kilograms times its velocity. Now, we need to remember that our velocity is a vector. And because the direction that the object is moving is important, momentum is also a vector scale. So we need to make sure we include the arrows when we're discussing momentum. So what would the units of momentum be? Well, they would simply be the kilograms times the meters per second. Those are the units for momentum. So if we had to solve a nice, easy question, we have an object with a mass of 20 kilograms, and it's moving east at a velocity of 5.0 meters per second. What is the momentum? And the momentum is quite simply going to be the 20 kilograms multiplied by 5 meters per second. The momentum here would be 100. Well, let's add another 0 there just to give us significant digits. 100 kilogram meters per second. Be sure that we've got the units in our proper fundamental units of kilograms and meters per second. Likewise, if we were given momentum, so let's say an object has, let's say a car has 2,000 kilogram meters per second um, of momentum, if it has a velocity of 2 meters per second, what is the mass? And very simple, momentum, let's get the vectors in there, is mass times velocity. If I want to know the mass would be momentum divided by velocity. So the mass in this example was it 2,000 kilogram meters per second divided by 2 meters per second. And we should see that the meters per second are going to cancel out. My units I'm left with are kilograms. So it's 2,000 divided by 2. The mass is equal to 1,000. Oh, let's get some significant digits here. 1,000 kilograms.